Titrations, calculations and curve. Graph of solutions, pH versus volume of acid of base added. Equivalent point equal to point which is pH and volume at which mole of acid equal to moles of base. As we know that the amount of the reactant are chemically equivalent. It might be at pH 7 or not depending on identity of salt form, and monitor pH with pH meter or indicator. Titrations, calculations and curve. Graph of solutions, pH versus volume of acid of base added. Equivalent point equal to point which is pH and volume at which mole of acid equal to moles of base. As we know that the amount of the reactant are chemically equivalent. It might be at pH 7 or not depending on identity of salt form, and monitor pH with pH meter or indicator.
Strong acid and strong base. pH will be neutral at equivalence point, which is pH equal to 7. For example, 25 ml of 0.1 molarity HCl are titrated with 0.1 molarity NaOH. What is the pH when 24.9 ml of base have been added? Step 1. Calculate the initial mole of acid HCl equal to molarity times volume 0.025 liter times 0.1 moles per liter equal to 0.0025 moles. Next, mole of the NaOH added 0.249 liter times 0.1 molarity equal to 0.00249 moles. Number 3. Calculate the remaining mole of HCl. The mole of initial HCl minus mole of the NaOH equal to 1 times 10 power of negative 5. Next, calculate the total volume of the solutions, which is equal to 49.9 milliliter, and convert to liter. Calculate the concentrations of H positive ions equal to mole of HCl over total volume, and the concentration of positive ions can calculate the pH, which pH equal to negative log concentration H positive, and the pH we get is 3.7. Still quite acidic even though more than 99% of acid has been neutralized. Then add 0.1 milliliter more base about 2 drops. First, we need to calculate the volume of the NaOH, which is 0.0249 plus the 0.1 milliliter convert to liter equal to 0.025 liter, and calculate the molarity of the NaOH after adding 0.1 more base equal to mole of NaOH over volume. The initial mole of HCl equal to mole of NaOH, which is same, means that it was at equivalent points, pH equal to 7.
For calculation of pH for excess of base, we add 1 more drop of base, which is 0.05 milliliter. Then we calculate the total volume of base, which is 25 milliliter plus 0.05 milliliter equals with 25.05 milliliter, which is equivalent with 0.02505 liter. Mole of excess base is 0.02505 liter multiplied with 0.1 mole per liter equal with 0.002505 mole. Mole of base minus with mole of acid is equal with 5 times 10 power of negative 6 mole. Concentration of OH negative ion is equal with 1.996 times 10 power of negative 4. Since OH negative concentration concentration multiplied with H positive concentration is equal with 1 times 10 power of negative 40. Thus, concentration of hydrogen ion is 5.01 times 10 power of negative 11. To calculate the pH, we use the formula pH is equal with negative log H positive. Then we get the answer, which is pH equal with 10.3.
Slide is a titration between strong acid and strong base. NaOH plus HCl will produce water and salt. So, the practice exercise. For the titration in previous example, verify the pH calculated for the addition of 40 ml of NaOH. So, based on the previous slide, we can see that 1.0 molarity of NaOH was added to 25 ml of 0.1 mol of HCl. So, to answer this question, this is NaOH plus HCl produce water and salt. NaOH, as we can see from the previous slide, we have the question have given the 0.1 mol of NaOH and 40 ml of NaOH, while there are 0.1 molarity of HCl and 25 ml of HCl. So to find the pH, we have to find the mole of HCl and NaOH by using the formula molarity over mole of molarity equal to mole over volume in liter. We can apply on this to find the mole of HCl. 0.1 mole is multiplied by 25 milliliter in liter. So we can get the answer. To find excess NaOH, we need to find unreacted mole. So mole unreacted is the bigger minus the smaller mole. So we get the answer 1.5 times 10 to the power of negative 3. And we also have to find the volume of solution. This is NaOH is 40 ml plus HCl 25 ml, which equal to 65 ml. So to find the concentration of AH, we use this formula, which is excess mole NaOH per divided by total volume. So the excess mole NaOH we find is the mole unreacted, which is 1.5 times 10 to the power of negative 3 divided by 60 divided by volume 65 in liter. So we got the answer 0.023 milliliter. Then we use the concentration of OH to find the POH by using this formula. POH equal to negative log concentration of OH minus negative. We substitute the value and then we get the answer, which is 1.64. To find the pH, as the question asks, to find the pH, we use this formula, which is pH equal to 14 minus POH. So 14 minus 1.64, as we get from the previous POH, we get the answer pH for addition of 40 ml NaOH is 12.3. 36 pH. The second question, what is the pH after 45.9 ml of NaOH is added? So I hope you guys can find the solution for this question. I will give the answer for this question, which is the pH for this question is 12.47 pH. By apply the step that I have shown.
Hello, my name is Nur Shahira. I will present for page 47 and 45. So this strong acid and weak base. So the equivalent will not be at pH 7 because the equivalent is because in the strong acid and weak base titration equivalent point will be acidic. So pH will be lower than 7. So need to determine identify an M of salt form and treating the hydrolysis problem. So this is example based on starting base and adding acid the titration the base with the acid. Hello, this is the graph of strong acid and weak base titration. So HCl is strong acid and NH3 is weak base. When it reacts together and it will form NH4Cl, which is acidic salt. NH4Cl is the salt form which hydrolyzes in water to produce an acidic solution at equivalent. Why equivalent point is lower? So this graph it starts with 11 because in the conical flask we fill NH3 first. So in the burette we will fill HCl, the strong acid. So when we react it slowly, so the equivalent will be lower because during the titration the strong acid HCl reacts with the weak acid HCl at the equivalent point. All the NH3 has been neutralized, leaving only the salt NH4Cl. So after the equivalent points, a strong acid and weak base combination does not form a neutral solution set, and it will become lots of acid in the conical flask then.
Hi, I'm Shahida Wisna with matrix number 102272. I'm going to briefly explain to you guys about strong base weak acid titration. So here we have acetic acid, which is partially dissociate in water, making it a weak acid. Sodium hydroxide here is a strong base because it is fully dissociate in water, producing sodium acetate, which salt that hydrolyze in water to form slightly basic solution. Okay, pH at the equivalent point is always greater than 7 due to the basic nature of the salt form. Basic nature of the salt form here. Okay, so based on this graph, starting point showing low pH, which is pH 3 because acetic acid, weak acid, and pH rises gradually as sodium hydroxide neutralize acetic acid, forming sodium acetate and water. Gradually increase. Okay, so before equivalent point over here, we have buffer region where both acetic acid and acetate ion coexist. The solution resists change in pH and the Henderson-Hasselbalch equation apply here. So at this equivalent point, this point, all acetic acid is neutralized, leaving only sodium acetate in the solution. The pH showing 8.72 here, indicating a basic solution due to the hydrolysis of sodium acetate. So here, beyond the equivalent point, adding excess sodium hydroxide increases the concentration of hydroxide ion, directly causing pH to rises sharply over here, and eventually it will go for straight line like that. Okay, that's all from me.
Now, we move to the next part. In this part, we will see some common acid-base indicators. Firstly, what is meant by indicator? An indicator in a titration is a substance that changes color to indicate when a reaction is complete. As we know, indicators are used to determine the endpoint of a titration, which is when the acid or base is completely neutralized. So, in this table, we can see different types of indicator. First is thymo blue. Thymo blue red in acid, yellow in base. Next, bromophenol blue. Bromophenol blue yellow in acid, bluish purple in base. Next is methyl orange. Methyl orange is orange in acid and yellow in base. Methyl red. For methyl red, methyl red is red in acid and yellow in base. For chlorophenol blue is yellow in acid and red in base. Next is for bromothymo blue. Bromothymo blue is yellow in acid and blue in base. Next is cresol red. For cresol red, it is yellow in acid and red in base. Lastly, the one that we're familiar or often use is phenolphthalein. For phenolphthalein, it is colorless in acid and reddish pink in base. We also can see that different indicator has different pH range. The pH range is defined as the range over which the indicator changes from the acid color to the base color.
For the titration curve of a strong acid with a strong base, the initial pH will start very low because strong acid will dissociate completely. When base is added, the pH will increase steadily and rise sharply nearing the equivalent point. The equivalent point is reached when the moles of acid and base are equal and the pH is equal to 7. The methyl red will change color from red to yellow when in an acid range of pH 4.2 to 6.3. The phenolphthalein also will change color from colorless to reddish pink in a basic range of pH 8.3 to 10. After equivalent point, the excess base will cause the pH to rise further, reaching the basic level. Next is the titration of a weak acid with a strong base. The initial pH will start higher than strong acid because weak acid does not dissociate completely. When strong base is added, the solution will form a buffer and the pH will change gradually and the pH will equal to pKa, which mark the halfway point to neutralization. At the equivalent point, weak acid will completely neutralize by strong base to form conjugate base. The pH at equivalent point is more than 7 because the conjugate base will hydrolyze, making the solution slightly basic. The methyl red will change color from red to yellow when the pH is at the range of 4.2 to 6.3, while phenolphthalein will change from colorless to reddish pink when the pH range is at 8.3 to 10.